Hello everyone, my name is Jashanpreet Kaur and today I'll be talking about my correct create mobility and how this program has helped me and given me an opportunity to learn about the skill that is very important for my research project. Before moving into my mobility, I would like to talk about my research background and the university I came from. I am a second year PhD student in Professor Janine Mosrol group in McGill University, and we are a very big group and we do very different kind of research in this group. The majority of the group focuses on the electrochemistry and corrosion aspect of the research. And me, I am also working on corrosion project, and the goal of my project is to develop metallic surfaces that has more corrosion resistance. Corrosion is a huge challenge. Government is spending a lot of money to replace and maintain these corroded infrastructure. If I just talk about Canada, approximately 3.4% of country's GDP is invested by government to replace these corroded infrastructure. Not just only expensive, corrosion is a dangerous process as well. Dangerous in the sense that each year many infrastructure fail due to corrosion, and this lead to damage to human life as well as environmental damage. So it is important to know about and to address these issues. I specifically work with copper metallic surfaces. Copper, like any other metal, have tendency to form an oxide layer, and this oxide layer can grow in ambient condition, and eventually the material starts to degrade over time. So eventually what we want to do is that we want to protect copper surfaces from oxidation and eventually prevent it from degradation. Recently, N-hydrocyclic carbene molecules have grabbed a lot of attention. This molecule has been developed by Professor Kathleen Cruden Group in Queen University under Carbon to Metal Coating Institute. What they have observed is that these N-heterocyclic carbene molecules have tendency to remove the oxide that is already present on the surface and also concurrently functionalizing the surface with N-heterocyclic carbene. The advantage of this process is that we don't have to add any external etching agent to remove the oxide. Only a single organic compound can do both functions. It can etch the surface and also prevent it from further oxidation. For the characterization of these metallic surfaces, I mainly use X-ray photoelectron spectroscopy. In McGill, I was able to acquire data using the machine that we had available in McGill, but at that time I didn't had any kind of knowledge how to fit the copper XPS data and to get quantitative information out of it. So Correct Create program gave me an opportunity to learn about this skill. And to learn about XPS, I decided to choose University of Western Ontario and Surface Science Western as my host institution because I believe that there is no better place to learn about XPS peak fitting than University of Western Ontario and Surface Science Western. I have spent this beautiful fall in the beautiful campus of University of Western Ontario. You can clearly see these images, how beautiful they are. Dr. Yolanda Hedberg and Dr. Mark Basinger were my hosts at University of Western Ontario and Surface Science Western, and I would like to thank them for giving me this opportunity. I would also like to say a special thanks to Dr. Jeffrey Henderson, who actually helped me and teach me the XPS fitting. I would like to show the standard XPS and OJ spectra for copper and eventually the fitted data and to see how complicated the XPS peak fitting is for copper. This is an example of copper 2p XPS spectra and OJ spectra. In copper 2p XPS spectra, I have indicated three different spectras for copper in different oxidation state. We can see that in blue color for copper 2 oxide, we had a characteristic feature. So whenever we have this characteristic feature that is labeled as satellite peak, It confirms that we have copper 2 present in the system. But if we look at copper 1 oxide and copper metal, there is no such characteristic feature present, and also there is an overlap of binding energies among these two. So using copper 2p spectra, it is very difficult to say in which oxidation state we have copper in. Whether we have copper in copper 1 oxide or copper metal, it is very difficult to say from copper 2p spectra. So it is important to fit Auger spectra, because if we look in the Auger spectra, we can clearly see that the peaks are very well separated at different kinetic energies. But the issue with Auger spectra is that the peak shape is asymmetric in nature, which makes the fitting of Auger peak much more complicated. But once we fit it, we can get the individual percentage of copper in different oxidation state, which is a very valuable information, especially for me. But in order to imitate these asymmetric peaks, we have to add 7 peaks for copper metal, 4 peak for copper 1 oxide system, 4 peak for copper 2 oxide, and 3 peaks for copper hydroxide. So this is how complicated the fitted data can look like for copper. But we can find many information for this procedures on Dr. Mark Basinger website. It has a fitting protocol for different kind of elements, which is very useful. That was all about my mobility. And this mobility actually motivated me to look into the history of London, how the city was built, and how this city hold connection with Indigenous people and their land. The city of London was founded in 1826. However, oral history and archaeological record shows that the London region has been inhabited for over 10,000 years. Some of the indigenous people who have continuously called this region home include Anishinaabe, Haudenosaunee, and Lenapehoak nations. But due to colonization and signed treaties, these lands were handed over to British Crown, and I'll talk about these treaties in few minutes. John Graves Simcoe, a British Army general, was scouting around for a spot to locate a capital city for Upper Canada. Apparently, it was love at first sight for Lieutenant Governor when he saw where the river forks at the west end of today's downtown core. The European settlement history of London begins in 1793. When Lieutenant Governor John Graves Simcoe selected the Forks of Thames as his choice for future site for the capital of the province. The London Township Treaty, a land purchase agreement between the Chippewas of the Thames First Nation and British Crown for the tract of the land located north of the Thames River, was signed on September 7, 1796. This treaty is also known as Treaty Number 6, and the signatories to the treaty included Alexander McKee, who signed on the behalf of King George III, and 13 chief warriors and people of the Chippewa Nation. Indigenous people have a vibrant and a long history with the land. The Western University campus is built upon the traditional land of indigenous people who have nurtured and cared for the land long before the entrance of settlers and colonization. Another treaty, that is the Longwood Treaty 1822, from pre-Confederate times, ensured 580,000 acres of land. The Longwood Treaty was also negotiated to provide $2,400 per year endlessly for the exchange of 3 million acres of lands upon which Western University is built. London has commemorated the relationship between the Chippewas and the Crown by celebrating the anniversary of London Township Treaty. By 1840, London was large enough to become an incorporated town. London has a diverse and extensive inventory of cultural heritage resources. The cultural value of London's extensive built heritage is one of the Canada's most significant, with over 6,000 properties listed on the City of London's Register of Cultural Heritage Resources. The main attractions are Eldon House, St. Paul Church, and Western University. For Indigenous communities, land means more than property. It encompasses culture, ecosystem, social system, relationships, spirituality, and law. But the question here is, are those lands are being used in a right way? Are those land are treated well? Indigenous communities are protesting in order to prevent their lands. The lands are being used and polluted with hazardous radioactive waste, and also the drinking water is being polluted with expanding pipeline network. Many dangerous projects are being conducted on indigenous land, and this pose a serious threat to the rights of indigenous people and also threat to their culture, land, water, and the wildlife. It is very important to understand here that this is not just a risk for indigenous communities. It is risk to everyone, because eventually that polluted water will be supplied to the households. The most famous example for polluting the indigenous lands with radioactive waste is the Elliott Lake case. Elliott Lake was the leading producer of Canadian uranium in the 1950s and 1960s. By 1959, the mine produced 74% of Canada's total refined uranium, or also known as yellow cake. Due to this process, millions of tons of waste was accumulated because during the process of mining, 99.8% of the ore became waste. This waste was left to pollute the surrounding environment in an unregulated way for decades, and it raised the water acidity and released harmful radioactivity. This pollution affected not only the people who inhabited the newfound town of Elliott Lake, but also those who had inhabited the land for over 500 years, the Serpent River, First Nation or Anishinaabe. There are few reports which indicate that in recent testing in housing in Elliott Lake indicate the high level of gamma radiation even today. Here you can see the two reports that I came across which indicates that in recent testing at 4 houses in Elliott Lake revealed elevated level of gamma radiation and concentration of radon gas far exceeding the safety guidelines. With this, we have come to an end of this video. I would like to say that it is very important to respect the rights of indigenous community in order to preserve their culture and their land. And it will be for the betterment of whole humankind. And also, authorities and government should ask for their consent before using their lands. In the end, I would like to say a thanks to Correct Create program for giving me an opportunity to express this journey. Thank you.